Right. In this tutorial or lesson, I'll be discussing deadlocks. I am following closely the textbook by Silvershats, and I'll be going through a lot of the issues they highlight in the deadlock chapter. Before treating deadlocks, I will assume you have some knowledge about how threads work, how processes work, how to use locks. It helps to understand what's going on. Two examples with code to show you how deadlocks occur or can occur. Right. So let's take a look at the banker scenario. Right. So remember we had a bank, and this is a banker. The constructor takes two accounts, account A and account B, and an amount. And what the banker does when it runs is to say, let me take some amount of money from account A and put it into account B, and it saves the balance. And then when I have debug on, so there's a static variable I defined. When it's on, I just print a message. I just want to show you how it works. The account is a simple class that has a balance variable. Now what I do is, for debug mode, I just use 10 items, or 10 bankers in this case, so that I can print and show you what's going on. But for larger numbers such as 10,000, it doesn't make sense for me to try and print everything because it's going to be very slow. I want to complete this resource or this tutorial for you. So let's go through all that's happening. So I'm doing a modulo here, meaning that I'm saying that all the, so this is 0, modulo 0. So all the even numbered bankers are going to be transferring money from account A to account B. But all the odd numbered bankers are transferring money from account B to account A. And what I'm doing is I put a fixed amount of money into account A and a fixed amount of money into account B. Now, if the total number of bankers is an even number, this is mathematics, and I'm moving from one to the other, or from the other, from A to B or B to A, that means, for example, banker 0 move from A to B, banker 1 will move from B to A, banker 2 will move from A to B, and so on. So if I can keep this going, then it means that at the end of this program, I expect that the total number of transactions one way should be the same as the total number of transactions the other way. So let me show you how this would work. So let's run this and see what's going to happen. When we run it, we see account A contains 1,000. What I do is I multiply the number of bankers by how much each person will be moving each time. And account B contains 1,000. Account A plus B is 2,000. And we start off. So this is what I was saying. Banker 0 moves from A to B. Let me just check this. I think there is a printing. Just see how I'm printing. Okay, so that was it. I have to. It should be B. This should be B. So you can see what's going on. So let's run this. So you can see 1,000 becomes 900 and 1,000 becomes 1,100. And for B, 1,100 goes back to 1,000 and 900 becomes 1,000. So that means every banker. So all the odd numbered bankers are doing the same operation. They're moving 100 from one account to the other. And all the even numbered bankers are doing the same. When running serial, so serial means I am running one after the other after the other. So let's look through my main. In my main, I simply call the run method, right, in the loop. And the run method, sorry, just jumped to the wrong place. Right, what the run method does, so this is my run method. The run method is simply moving the money based on the transaction. So even if I had 10,000 items, so for example, if I say I'm not debugging anymore, false, I want to run with a full speed, so this is 10,000 bankers, and I run this, I am now going to have, at the end of the day, 2 million was the end amount, and previously was also 2 million. Now let's take a look at transferring. A poor case of transferring. What I've been doing is anytime I do example code, I show you one example where there are errors. So in this case, this is the second example. Starting again, the transaction is there, but in the run method, I am not using any locks, but I am still going to be using threads. So you can see I have If debug, I do some things, and what I'm going to try and do is to print the information using the variables. So this is A and B. Right now I'm going to go through, we're going to look at the main. So I can see here I have 10 items, 10 banks if I'm doing debugging. Let's run it and see what happens. Right, so okay, so this is when I'm not doing debugging and I'm running everything. You can see that I actually end up, initially I had 2 million in units, but at the end, if I'm not using any type of synchronization, no locks, I end up having the wrong value. So let's run this again so you can see what's going on. Right, again. So I think the threads are running. Run. Wow. So I get different values. It's close, but it's different values. I run it again. The threads are running. So I keep getting different values. Now, when I am debugging, so when I turn debugging on, I use fewer number of bankers so you can see the messages that are being printed. So when I run this, you can see it says banker A was using this, was using that. Even though it's printing that it's locked, it didn't actually lock it. Remember I said for this specific case, I am not doing any locking, but I'm still going to try and do threads. So you can see each person is saying what they're doing. And if you go through carefully, so here's a good interesting example. One banker moved an amount. Let me just try and find an example. Okay, so this one is so small that it doesn't really matter. Remember, for small numbers, sometimes you will not see the error show up. But when the number of bankers grows, so in this case, when I moved to 10,000, then I started to see cases where the amounts were not adding up. So these are, the bankers are moving money from one to the other, and again, they don't add up. It's by a small amount, but if you're a computer scientist, you care about little details, right? So let's look at the deadlock scenario. Remember with the deadlock scenario, so let's pull up our presentation and look at the deadlock. Just scrolling all the way to the beginning. This was a deadlock scenario. Banker 1 was holding this account, this banker has this account, and each one is also waiting, so that's a deadlock. Let's look at how we can have that happen in our code. Alright, so we are going to be looking at using locks, and even though we are using locks, I'm going to show a scenario in which deadlock occurs. Now, if you look at our code, we have in our run, this is someone saying synchronize on account A and then synchronize on account B. But if you look at this, it means for somebody, for example, moving from A to B, this one will say synchronize on A, and this one will say synchronize on what I think is my first account. But if I am seeing my first account as account A and he's seeing his first account as account B, that means that one thread is holding A, one thread is holding B. And the reason why this is occurring, we'll move down into our where we set up the initialization of the constructor. So if you scroll up a bit and you look at your constructor, it says account A, account B. It means I'm passing two account variables, and so whichever one I pass first would be locked, and the second, in this case, the second item would then be locked. And if you look at this, that's exactly what it's doing. It says lock up my first account, lock up my second account. And if I scroll down a bit, this is where I have my main, and in my main, if you keep scrolling, you'd find where I create the bankers. For the even bankers, the first account is A, for the odd bankers is B, and for the even, the second account is B, whilst for the odd, the second account is A. So it means these guys are going to lock up this one first, meanwhile the B's are locking that one. So in order to show you how the deadlock will occur, I'll run this first with debug mode on. That's the banker, that's the debug, it's on, and that means it will be using 10 items or 10 bankers to run this. So let's run it. Okay, a deadlock has occurred even though they're just 10 items. So just going to resize trying to resize my window here. So it says running, right, running, and you can see here it says banker 0 went ahead, banker 1, banker 2, but no, it gets to a point. Look at this, it says banker 7. Actually, that means you don't have control of when threads start. I created a bunch of threads and they're just running, didn't have any control. So thread 7 actually got a jump on thread 6, and thread 7 had locked up account B and thread 6 had locked up account A. Then it stopped. Now, one of the reasons why deadlocks are dangerous is sometimes if you have bad code, it will happen, and sometimes it won't happen. So it's possible to write code you keep testing in your test facility with all the software, and you will not detect the error. Let me run this again. So I stopped it. Let me run it again. It's even stopped earlier, 5 and 6. Now, there will be some cases. So sometimes you'll have a scenario where this is just getting worse and worse, right? Like in this case, right off the bat, it froze. Try again. This time it went a little bit further. So it means that these are sort of non-deterministic runs. We can't tell when a deadlock will occur, because whenever we run it, depending on how lucky we get, it may freeze up, right? So it means we are running into a scenario where one is grabbing the other and the other is grabbing another, and we are running into a deadlock scenario. Now, if you're doing a test and you want to see if this is really happening, one of the things I do, this is not something I would say everybody should do, but one of the things you can do is you can sometimes during testing do thread.sleep. You just need to sleep for a very short period of time, and what that happens is you are letting go of the processor. I believe there are other methods available. There's also yield. So you can say I want to give up my my share of the CPU immediately and let someone else take over. You come back. So if you are having a scenario where you're running it and you've set up the scenario, so this is for other lecturers, teachers, professors, whoever, you're trying to set up a scenario and it's not working, I just want to point out to you that you can tell the process, on this case a thread, to sleep. And when it sleeps, usually it means that it will let go and someone else would have a run and the deadlock can occur. But of course, I do like my examples. It seems everything is working, and as I said, I will share my code so students can test it out. Let me just comment this out in case someone wants to uncomment it and see how it runs. Of course, you can, if you really want to force the deadlock to occur earlier, you can make the sleep value larger. So let me just show you how that happens. So you see, that means because I made the sleep value larger, it means he didn't even sleep for long. So I force almost the first and second thread to lock up. And people sometimes say, oh, but the sleep is artificial. And I say, yes, it is an artificial sleep. But in a real world scenario, you don't control when sleeps happen or when the kernel will be preempted. So you should, especially in testing, test out all the scenarios. People have written their own packages for doing these. A lot of them are available. And this is just a hint to those who do tests. You can put in sleeps. If your code is good, it doesn't matter where it sleeps, it should work. Right? It should work. Now, so it doesn't even make any sense to say I'm not going to debug, but I'll just do the false case where I'll say I want to run this with 10,000 threads, and I am sure this has frozen as well. See, it was running for a while, it just froze. Okay, so let me stop this. The other thing I can do is I can run it in debug mode. It's running and it's frozen. If you have your debugger on, so I have my debugger on, I'm just going to hit pause so you can and while paused, I'm just showing you all the different threads, and some of them are suspended. Of course, things are still moving around. You can try and go through it and figure out who has which thread and so on. But I'm just showing you, there it is. This is NetBeans, deadlock detected. So some of the tools like NetBeans are really have advanced features, and it's saying a deadlock has been detected, and it's just using some of the things we talked about in class. So some of the debuggers can do this. So sorry, that's another output of a run. This is a debugger console. That's the one saying deadlock has been detected. So this is a really cool feature of the debugger. At least this is NetBeans. I don't work for NetBeans or have any formal association with them. I just use the tools. So let me stop everything and let me run this again for those who are wondering how did this happen. So I run it in debug mode. And even though I don't have any breakpoints, I believe it's still able to detect the deadlocks. I'm just running it again. And you see, it keeps running different threads. It's running. And as you watch the list over time, that's the output. I have a lot of threads going on in there. If this takes too long, I'll pause it and I'll let you take a stab at it when there are few items. Let me see if I can make this run with few items and see if I can get the deadlock detected, maybe for a smaller number of threads. Okay, and debug mode. If you have a lot of variables being tracked during debugging, it can sometimes slow things down. Okay, so for 100, I didn't run into, and that's what I was just saying. Sometimes you don't run into these deadlocks, and other times you do. Right. So let me look at my. Sorry. I'll save this. You can play with this on your own time. Let me look at the last scenario, and that is some code where there is no deadlock. Right. And the way I did this was to simply say, and you remember what we said during the presentation, especially preventing deadlocks. For the last item, circular wait, we said we can assign strict request order for the resources. And I'm just being creative here, but what I did, if you look at the implementation of Banker, this new version, what it does is to pick up the accounts and find out by the name order. So we'll read the name of the account and find out which one comes before the other in sequential order. So if its accounts are called A, B, C, D, it means A will come before B, B before C, C before D, and so on. And whoever is first is going to lock that one before locking the other one. And that is going to force an ordering on the way locks are done. And that will prevent deadlocks. Right, so I'm going to take a look at this. This is when debugging is true. So I'm just going to start with make it print the messages. So this is for no deadlock, run it. So it ran to the end, everything looks good. Let's do this again when debugging is false, and this means I'm running with 10,000 bankers. Let's try this, show you it works. Of course it's breathing. Yes, it worked, and all the numbers are right. So I want to show you, if you write good code sells itself. Right. So thank you for watching the Java part. Hopefully this takes you through some of the things you can do with code. Now, there were many other things listed during the presentation. I believe you should be able to implement these yourselves. Just listen to the description and then just implement away. Hold and wait, no preemption. All of these you can code. Alright, let's continue.